So this week we're moving on to look at how we can multiply two vectors together, kind of finishing the book on our basic vector arithmetic, where to do this, we can first think back to some of those early things we talked about in chapter 8 with matrix multiplication, where for that, we always worked in terms of matching up elements, multiplying them together, and then adding up the pieces. And that general sort of construction, even though we didn't talk about it in this way then, is actually an example of a dot product, where in particular, for this case, when we're talking about the dot product or inner product, we're not going to use that terminology too often in this class, but it is technically the same sort of idea. But when we are talking about a dot product, we are multiplying like terms and then adding them up. So if we have two vectors, a1i, b1j, and a2i, b2j, and we want to take the dot product of them, we just multiply the a terms, multiply the b terms, and add them up. Where it's important to note that when we take the dot product of two vectors, we will get a scalar value. That is, we'll just get a number, not another vector. So, if you want to get some examples for how this works, if we have vectors v equals I plus 3j and w equals 2i minus 5j, and want to compute v dot w, w dot v, and v dot v, in our first case, for v dot w, what we want to do is match up our terms, multiply and add, where in this case, because we have a 1 implicitly attached to that I on v, we're going to have 1 multiplied by the 2 for the I on w, plus 3 from the j term, the vertical component on v, multiplied by the vertical component for w, which is a negative 5 in this case. So we'll get 2 plus negative 15, or negative 13. And then going in the other direction for the second case, for w dot v, we'll get something very similar, just in a slightly different order. We'll have 2 from w times 1 from v, plus a negative 5 from w times 3 from v, but we'll end up back at negative 13 again. And then finally, for our last case, if we want v dot v, well, we'll have the 1 from the first v times the 1 from the second v, plus the 3 times the 3, get 1 plus 9, or 10. And in general, there are a few known patterns that we have for working with dot products. That is, if we have two vectors u and v, u dot v is equal to v dot u. If we have u dot v grouped together dot u, we can split up that grouping as u dot the group v dot w. If we multiply the 0 vector times v, 0 dot v, we get the scalar 0. If we take v dot v, we get the magnitude of v squared. And then if we take in a constant multiple, we can essentially rearrange that constant multiple however we want to in order to group things up in whatever way happens to be the most convenient for what we're trying to find. And from here, we can then talk about using this idea in maybe a not obvious way with geometry to get an expression for the angle between two vectors.